Hey guys, today we're doing a lesson on transformations. There are four different types of transformations. The first one being a translation. A translation is the same thing as a slide. So translations go side to side, up and down. So translations, we have horizontal ones. And so horizontal slides go left and right. And then we have vertical, which goes up and down. All of our translations will go in one of these four directions. An example of that. We can translate vertically, which is up and down. So this one just translated 1, 2, 3, 4, 5, 6 units down. Or we can translate horizontal, which is right and left. And so this one just translated 1, 2, 3, 4, 5, 6, 7 units right. So these are examples of translations. Our next type of transformation is a reflection. And a reflection is the same thing as a flip. So when you reflect over something, you have to have something to flip over. That's usually a line. So we have different types of lines here. You can reflect over the line x equals some number. So any number here, whatever number they put, if you're flipping over x equals a number, you're flipping over a vertical line. If you have y equals some number, so any number, it'll be a horizontal line that you're flipping over. If you have the line y equals x, that's a positive slope. So it's the diagonal line that goes up with a positive slope. Or you can reflect over the line y equals negative x. It has a negative slope, and therefore it goes down diagonally. So these are the four types of lines you'll encounter whenever you're doing a reflection, and you will flip over these lines. An example of that, you have to have your reflection line. So because I have a vertical line here, this is a line at x equals 2. I know it's x equals because it's vertical, and I know it's at 2 because it's at 2 on my number line here. So a reflection flips over this line, and you know the reflection is right by the point. So this point here is 2 units away from the line. Its reflection point should also be 2 units from the line. Up here at the top, this point is 1, 2, 3, 4, 5 units from the line. So this point should be 1, 2, 3, 4, 5 units from the line. That's how you know it's a reflection. The next one we have is a rotation. There are two types of rotation. We have clockwise and counterclockwise. A clockwise rotation is going to go with the clock. So I've drawn a clock here for you. Clockwise rotations follow the clock in order. So starting at the top, I'm going to go in order of the clock, going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is a clockwise rotation. So the opposite would be a counterclockwise rotation. Counterclockwise always also starting at the top, but this time instead of following the numbers of a clock, you're going to go the opposite way. So you're counting down from 12 all the way to 1. That's going to make a clockwise rotation. A counterclockwise rotation. So clockwise follows the clock, goes in order with the numbers. Counterclockwise does the opposite. It goes the opposite. It counts down with the numbers. Now an example of that would look like this. So whenever we rotate based on degrees. You know that 360 degrees is a full circle. So if you rotate something 360 degrees, it's just going to end up right back on itself. So this is my original. I can rotate it 90 degrees clockwise. I abbreviate this CW. Counterclockwise would be CWW. So 90 degrees counterclockwise It rotates like that. Now I'm rotating about the origin. That's the point in the middle here. You don't have to rotate about the origin, but that's most likely what you'll see. We may do a few examples where we rotate about other points. So this one, if you notice how it matches going down the axis, I'm going down 1, 2, 3, 4, and then into the grid 2 to get that first point. Here, now that I've rotated 90 degrees, I can go down this axis, 1, 2, 3, 4, and into the grid 2 to get that point. When I rotate 180 degrees, it's now over here. So this kind of looks like a reflection, but it's not quite the same. Notice it's not exactly over. So when you do this, 1, 2, 3, 4, and then into the grid 2. And then the last one would be a rotation of 270 degrees clockwise down the grid 1, 2, 3, 4, or down the line 4 into the grid 2. So rotations can be kind of hard, so I found it a lot easier if you count down the line, down the axis, and then into the grid to get your points. Now, a 90-degree clockwise one would be the same thing as a 270 counterclockwise. And vice versa over here. This green one was our 270 counterclockwise rotation, but it would be the same thing as the 90 degrees counterclockwise. So you just kind of got to remember which way the clock goes as to which one is which. Our last type of transformation is a dilation. And a dilation just makes something bigger or smaller. So with our dilation here, I've marked this one as the original rectangle. It's a 1/2 rectangle. So if I was to do a dilation of 1/2, that means I'm going to cut it in half. Well, anytime you cut something in half, it gets smaller. So anytime I have a dilation that's a fraction, it's a fraction meaning smaller than 1, so not an improper fraction, but just a fraction that's smaller than 1, it's going to get smaller. It's going to be a dilation by 1/2. So now, instead of having a side of 1, it's 1/2. Instead of having a side of 2, it's 1. But dilations go in both directions. I can make it smaller, or I can have a dilation that makes it bigger. Anytime I have whole numbers that are my dilation, so this one's a dilation of 2, which means it's 2 times as big as this one. So my side of 1 is now 2, my side of 2 is now 4. I can even go even bigger and have a dilation of 3. So my side that was 1 is now 3, and my dilation of 2 is now 6. This one is 3 times bigger than my original. Dilations just get bigger and smaller. So to show you that in the program, here's my original triangle. I can have a dilation of 1/2. Notice it gets smaller. Or I can have a dilation by 2. Notice that that one's going to get bigger. It's twice the size of my original. So these are 4 types of transformations. We have dilation, rotation, translation, and reflection. Oh, I guess I should put here. We didn't have it. A rotation is the same thing as spin. So a translation, just for kind of layman's terms, a translation is a slide. It slides side to side or up and down. A reflection is a flip. You're going to flip over one of these lines like a mirror. A rotation is going to spin. You're going to spin around either clockwise or counterclockwise. And then your dilation is going to get either bigger or smaller.